Welcome to aminacademy.com. In electrical engineering, let us discuss about Gauss law. Consider a point charge Q lying at the center of sphere of radius r, which surrounds it completely. Here, the total number of tubes of flux originating from the charge is Q and are normal to the surface of the sphere. The electric field E, which equals to Q over 4 pi epsilon 0 r squared, is also normal to the surface. As said earlier, total number of lines of force passing perpendicularly through the whole surface of the sphere is Q over epsilon 0. That is a Gauss law. We will discuss further. The total of the electric flux out of the closed surface is equal to the charge enclosed divided by the permittivity. Therefore, phi electric is Q over epsilon 0. The sum of the flux is proportional to the total charge enclosed. The electric flux through an area is defined as the electric field multiplied by the area of the surface projected in a plane perpendicular to the field. Gauss law is a general law applying to any closed surface. It is an important tool since it permits the assessments of the amount of enclosed charge by mapping the field on the surface outside the charge distribution. For geometries, a sufficient symmetry, it simplifies the calculation of the electric field. Now, Gauss law in integral form also you can explain. The area integral of the electric field over any closed surface is equal to the net charge enclosed in the surface divided by the permittivity of space. Gauss law is a form of one of Maxwell equation of four fundamental equations for electricity and magnetism. Here, integral E vector into delta A equal Q over permeability of vacuum. Gauss law permits the evaluation of the electric field in many practical situations by forming a symmetric Gaussian surface surrounding a charge distribution and evaluating the electric flux through that surfaces. Now, what is electric flux? The concept of electric flux is useful in association with Gauss law. The electric flux through a planar area is defined as the electric field times the component of the area perpendicular to the field. The component of area perpendicular to the field, here, this is area of the plate. Then the evaluation of the flux generally requires an area integral since the angle will be continually changing. Here, phi equal integral E cos theta delta A. This is an integral form of electrical flux. When an area A is used in a vector operation like this, it is understood that the magnitude of the vector is equal to the area and the direction of the vector is perpendicular to the area. Now we'll discuss about application of Gauss law. Gauss law is a powerful tool for the calculation of electric field when they originate from charge distribution of sufficient symmetry to apply. Look at here the point charge is surrounded spherically and line charge like a cylinder, sheet of charge, conducting sphere, conducting cylinder, sphere with uniform charge density, cylinder with uniform charge density. We can use these options to the Gauss law. Now, what is Gauss law formula? As per the Gauss theorem, the total charge enclosed in a closed surface is proportional to the total flux enclosed by the surface. That is, a total flux enclosed by the surface is a Gaussian formula. Therefore, phi is total flux and epsilon 0 is the electric constant. The total electric charge Q enclosed by the surface is Q equal phi into epsilon 0. That means phi equal to Q over epsilon 0. The Gauss law formula is Q phi equal Q over epsilon 0 where Q equal to total charge within the given surface and epsilon 0 is the electric constant. Now we'll discuss some application of Gauss law. In the case of charged ring of radius r and its axis at a distance x from the center of the ring, we can find. Then in the case of an infinite line of charge at a distance r equal to 1 by 4 pi r epsilon 0 into 2 pi over r, that is equal to lambda 2 pi r epsilon 0, where lambda is the linear charge density. The intensity of the electric field near a blank sheet of charge is equal sigma over 2 epsilon 0 k, where sigma is surface charge density. The intensity of electric field near a plane charged conductor, that is equal sigma over k epsilon 0 and a medium of dielectric constant k. If the dielectric medium is air, then E air equal sigma over epsilon 0. The field between two parallel plates of a condenser is equal to sigma over epsilon 0, where sigma is the surface charge density. That means Gaussian law used this field like a spherical space and radial cylindrical space as well as line integral. All this form that Gaussian law is applicable. We have done. Please subscribe our YouTube channel.